Very well, and welcome to you. It's Jim from maverickstar Observatory. Good morning. So here we are. We're in the last month, the last 18 days before we reach, that theoretical 40-degree mark. 2.5 years we've been predicting this point in time, and this month we will reach that destination of 40 degrees. What do we expect to happen? Well, I wouldn't expect anything too dramatic. It's not like we're going to hit this spot and then all of a sudden the fireworks are going to start going off. And the reason for that is what we have to remember is that we're dealing with large inertias. Let me give you an example of a large inertia, or objects with large inertias and very slow activity. The core of our planet is around 4.5 billion years old, and it has been superheated up where it will melt, even to this day, liquid iron into liquid, and other metals as well. And it has been that hot for 4.5 billion years, simply because of the size and the mass of the core of our Earth. So it's taken that long to even cool down to the very, very small amount that it has over that period of time. We're talking 4.5 billion years is when the Earth was actually created, and yet this core of our planet is still hot from that very day when it started to accumulate more mass and become a planet out of the interstellar gas that created it. So when we're dealing with large inertias, we can understand that, when we're looking at pole shifts and magnetic reversals, why they take so long to reoccur. The last one, obviously, was 780,000 years ago, and before that, every 350,000 years, we would go through a reversal almost like clockwork. Up until this point in time, there's something different on the historical records. When we look at the magnetic reversals going back millions of years, we can see that we're definitely in an unusual period. And the reason for that is because we have gone nearly 500,000 years without any reversal of completion. We have had excursions where the magnetic poles have flipped temporarily but gone back to their original positions. They're called excursions. The last one happened around 12,000 years ago. And between the last completed magnetic reversal and to this point in today, we have had many of these excursions. Are we going to face another failed reversal? That's the question. There's no longer a doubt of whether the Earth is going through either an excursion or a completed reversal, because we know that that is taking place already. The poles have drifted further than they ever have done in any fixed period of time, going back 12,000 years and also going back 780,000 years. But what do we expect to happen? Well, we know that when the core of our planet goes through these processes of reversals or excursions, we know that it affects the dynamo which generates the dipoles on our planet, which we call north and south poles. And in turn, it also affects another key component of geomagnetics, which is the magnetosphere. It weakens the field strength, which is our primary protective shield against harmful radiation, not just from the sun, but from out of our solar system, or galactic cosmic rays is what we're talking about here. And we also face another problem which I mentioned, which is 3 solar cycles in concession that have showed low solar output, and we're about 2 years away from the next solar maximum, and the numbers are already down, and it seems like that trend is continuing. So we could see the end of this solar cycle excuse me, being or following suit on the last 3 that we've witnessed. And what that means is that our heliosphere, which is like a magnetosphere but protects the whole of our solar system, will begin to reduce in strength. or has been reducing in strength for the last at least 3 cycles and this cycle. So we're talking probably around about 35, 36 years at the moment. So we've seen a pattern of depleting sun activity. So that shrinks the heliosphere, which is our solar system's protection from galactic cosmic radiation from outside of our solar system. So we know that more radiation is coming through, more cosmic rays are coming through our heliosphere. And we also know that during a magnetic reversal, our magnetosphere, which is our primary protective field, which protects us from solar radiation and also cosmic radiation from outside our solar system, that is weakening, and it is weakened to about 23% at the moment. And that will enable more cosmic rays into our upper atmosphere, which will create more muons, which is one of the subatomic particles that we monitoring here and in Canada. And we have got a muon detector down in Australia, but we rarely get data from there. I know Jeff's very busy and he does send us the data when he can, so hopefully we will get some more data on that at a later point from Australia. And of course we're interested in what's going on in Australia because they are closer to the south magnetic pole on our planet, which is technically the north. Okay, I know it sounds crazy, but yes, it is actually a north pole in the southern hemispheres. But we just talk here on the channel as it's the south pole and the north pole to save confusion with people. Yes, the north pole is actually a south pole, but putting that aside, we are, as we have been anticipating for the last 2.5 years here at this observatory, reaching a very interesting point. And we theorized that based on some experiments, some very, very crude and very simple experiments, that we could see something change gear at this point. And what we mean by that is we could see a vast increase in the speed over distance over time, with the magnetic North Pole now migrating much faster towards the west. We know exactly at this point in time where the magnetic North Pole is going, and we know why it is going. And you guys up until this point have never been told that by mainstream, and I wonder why that is. We know it's heading towards Russia, central Russia, because there is a magnetic intensity which has been building up for the last 8-9 years in that region. And it has slowly began to, if we go back 120 years, that was when the point it started to change over in Russia originally, which is what led to the pole migrating in the first place. It was two things that was happening. First of all, where the pole was anchored for the last 780,000 years over in Canada region, that intensity over there has been weakening. We can show you, videos of that weakening over a 15-year period. You can see recently it's dramatically dropping off now, and that is why the pole is accelerating over the northern hemisphere. At the same time in Russia, that pole, or that magnetic intensity, has been increasing. Now you could do this experiment yourself if you've got a compass and 2 magnets. Put the south poles facing the compass and then just back one off slowly, and what you'll see is it will go over to the one which is closest. If you bring it back to the same distance, if they're equal strength magnets, you'll see that the compass needle will point in between the 2 magnets. This is the situation right now on our planet. Where the magnetic North Pole is pointing is not the strongest intensity as it should be. It's being fought over between the weakening magnetic field in Canada and the strengthening magnetic field over in Russia. And it is because there are 2 magnetic poles or high intensity regions on our planet at the moment that the magnetic compass points in between the 2. This is something that's not been shared with you, because the reality is that we do actually have 2 magnetic poles over the northern hemisphere and 2 over the southern hemisphere. But because there is 2 over the northern, 2 over the southern hemisphere. The actual dipoles of our planet are pointing at neither intensity, which is very unusual. I'm sure that these other departments like NASA, NOAA and the ESA are completely aware of what the situation is. And, getting back to the point of where we are right now, 17 days or 18 days or so away from reaching, that 40-degree mark. It was when we was conducting experiments with a compass and an external magnet, and I've been criticised for this not being as is the Earth is, the Earth's model. So it's it's going to give, if they're saying, what they're saying is you put errors in, you put errors out, but I don't think they've quite understood what the experiment represents. If I was stood here right now with you and I had a compass in my hand, that would be one magnetic object, and it would be relying on the Earth's magnetic field to show us. If that changed, then obviously the compass would change. So there's 2 magnetic intensities, just like the experiment shows 2. We've got a rotating magnet, which represents the rotation of the magneto in the core of our Earth, and we have the compass, which is just the indicator, or the visual ability to see what's going on with either the magnet that's rotating or the core that's changing during a reversal. So I think that the experiment's quite accurate. So we've reached a point 17, 18 days from now, we hit 40 degrees. And the reason why that is important is because in this experiment, when we saw every single time the compass needle get to 40 degrees, it was no longer a slow transition. It rapidly rotated over to the South Pole. And this has been understood by volcanologists that are studying lava flows, and they done some core examples. As the lava flow went further down the volcano, it showed that at that point of the lava flowing, and when it solidified, it had trapped magnetite in the molten lava, which is magnetic material, which is able to align itself with the pole at that time. It had trapped it in the direction of the poles at that time as they was reversing. And they stated during this excavation of these core samples that you would have probably been able to see at that very time on your compass the compass needle moving gradually over towards south. It had taken place that quick. So it is an indication that things can rapidly move, as the experiment showed. We know why the experiment shows the slow movement at the beginning and then the rapid movement at the end. It's because the poles, or the needle of the compass, during a rotation of the magnetic core of our Earth, or in the experiment the magnet itself, it reaches a critical point where the needle is slowly migrating as it gets towards 40 degrees and then rapidly migrates after 40 degrees. It's because of the strong field lines, which enables a slow movement, come to an end, and it meets almost a wall where the strong field lines go into weak field lines. And once it hits the weak field lines, it enables the compass needle, or the magnetic poles on our planet, to rotate very quickly. And then it would not go a complete 180 degrees. It would reach a point where, in the next 100 years, like we've seen now, it will go back through the weak field lines and fixate at that current position if it's not an excursion. If it becomes a fixed magnetic completed reversal, it will hold that position perhaps for 300 or maybe 700,000 years if something has changed in our core. Now, this has been explained by another Californian professor in another way. Basically what he's came out and announced now, and a few other universities have agreed with him, is that the core of our Earth is slowing down, that it could possibly stop, and that it could possibly reverse. That's very interesting, because A month before this was announced by this university, we stated that we started to witness strange anomalies taking place with the magnetic poles. What we witnessed was the pole not migrate at all over a month's period of time. And then a month later, we had witnessed the poles go back towards an easterly direction. And in the 4.5, 5 years that we've been recording magnetic data, that was the first time we've ever recorded that happen, so it was quite a big thing. And then it started to move forward again, and then from that point it has been picking up speed. Yesterday we saw that it done, was it off the top of my head, 3.1 miles now. So over the month we're talking about 6.2 miles per month. It's the fastest we've ever recorded the pole moving, and it shouldn't come as any surprise if the experiment plays out to be right, is that this is the critical point in time where we should start to see, activity accelerating with regards to the dipoles of our planet. So we will do for you guys around about the 17th, 18th of this month, a pinpoint position of the magnetic pole, and what we're expecting to see, although it might not be the case because we just record what we get, what we're expecting to see is maybe a slight increase on that speed, as we are now at that critical point in this theoretical understanding of perhaps geomechanics that is not widely known. And this is new territory for any scientist studying this topic of geomagnetics, because we have no historical record other than what we have in the Paleolithic records, in the geological records that have been frozen either in the mid-Atlantic ridge, where the lava flows on both sides and we measure the magnetic reversals going back millions of years, or indeed volcanic eruptions that have happened during a magnetic reversal. Those are the only records we've got, and proof, solid proof that this Earth does indeed go through a reversal. What we could expect to see during a reversal, if we do start to see an uptick in the speed of the migration, is a further weakening of the magnetosphere, and that's not good for us, because I'm in the belief that we're already starting to see an increase in cancer cases, carcinogenic interference through or via cosmic rays. And I also believe that what we're seeing now with the increase in rate of cardiac arrhythmias across all age groups at the moment could also be, may not be, but could also be the reason that we are experiencing more cosmic radiation through our upper atmosphere. And obviously the more that our magnetosphere weakens, the more cases that we are going to see of people having cancer, and across all age groups, people having cardiac arrhythmias arrest. So those are two primary concerns that we have here. But we also know that we are overdue a coronal mass ejection from our sun, a large one. And what we're talking about here is something in the lines of the last large one, which knocked out the only technology at the time, which was the telegraphs. And we're talking about the Carrington event during that time. I believe in the 1800s that happened. And it wiped out the only technology, which was, those telegraph poles. Today, if we was to experience that, well, you can imagine these energy companies that provide the electricity to our cities across the world are not geared up for such a thing, because it would blow every transformer. And that's just, looking at the grid situation. It would also knock out every CPU in any advanced technology that we've got. So any computers, phones, anything electronics, electrical, it would knock out that as well. And that would, I'm sure you'll agree, put us on the path back into the dark ages. because we can't replace all this stuff, and we're heavily reliant on this stuff. You know, the traffic lights run on these things, the trains run on these things, aircraft run on these things. You know, ships' navigation systems run on these things. You know, the ship's management systems run on these things. You know, and we are ill prepared for this. You know, the money that our world governments have invested in, you know, solar power, wind generation, and reducing our carbon footprint would have been more wisely spent on protection for this coming event. It would have, and there has been, to my knowledge, nothing invested at this point in time. So we are definitely going to be caught during this next event with our pants, so to say, down. So, you know, hopefully that gives you something to think about. I wanted to cover a few of the things in this video, but, you know, I think it's gone on way too long at the moment. You know, I don't want to keep you from, you know, your weekend. So, you know, I think I'll just take this point in time to thank those people over the last couple of days, you know, for their contribution towards this research that we conduct here at the observatory, and, you know, try and encourage a few more of you. You know, at the end of the day, you're not getting this information, and you're not being told the truth on this topic, which should be, you know, on your minds, maybe not every day, but at least once a week, because these events are slowly but surely happening. You know, we monitor the magnetic pole migrating every month, every half month. We see it's still progressing towards the west, and we know that further it goes, you know, it has a weakened effect on our magnetic machine that generates our dipoles, our magnetosphere. I'm talking about the magneto in our core of the Earth that generates all these things, is slowly weakening or slowly slowing down, as has been now confirmed by, you know, professors out there in the fields. So, you know, with that, you know, there is a link down there if you want to get behind this small observatory, which is the beacon of light in this field, really, for you guys, because there isn't another one that does exactly what we do. And of course we cover other anomalies as well, like CO2, atmospheric oxygen, the amounts of volcanoes that are erupting every time we look at the Earth's Alpha at a glance. You know, all those details for you. You know, we monitor the muons, the magnetometer data from other countries, and of course we have the TriMag here in the UK for you guys. So we don't charge, it's not mandatory either, but there is a link down there if you want to get beyond a real observatory, really making a difference for the individual Joe Public like yourselves. It's entirely up to you. The link is down there. And I'll say what I usually do. You know, guys, you take care of your loved ones. Have a good day, as always. Bye for now.